Hey guys, it's Mr. Wigand. Today we're going to look at solving one-step equations using inverse operations. The first thing we need to talk about is inverse operations itself. We have four operations that we're going to look at today: adding, subtracting, multiplying, and dividing. The inverse of adding would be subtracting. The inverse of subtracting then would be adding. The inverse of multiplying is dividing, and then the inverse of dividing would be multiplying. So we're going to be working with these ideas of inverse operations when we solve. Another idea that you want to think about is an equation is kind of like a balance scale. A balance scale balances on a fulcrum in the middle, and whatever you put on one side of the balance scale, you would have to put the same weight on the other side to keep it balanced. And that's what an equation is. It's kind of like a balance scale where your equal sign is your fulcrum. Whatever you do on this side of the equal sign, you have to do the same thing on this side because you always want to keep it balanced. All right, so let's take a look at this first equation. X plus 7 equals 15. I'm going to copy that down because I never want to do my work on the problem itself. I always want to rewrite that problem. All right, so we have x plus 7. Adding is our operation. We want to do the inverse of adding. That'll be subtracting. So right underneath plus 7, I'm going to write minus 7. Remember, whatever I do on one side of the equal sign, I have to do on the other. So underneath this 15, I will also write minus 7. Doing the same thing on the left side as I do on the right side. All right, now, 7 minus 7, that's 0. They cancel. And that's exactly what I want, because I want to isolate this variable. I want to get rid of that number so that I get x by itself, because that's really what I want to know. I want to know what x equals. I want to solve this equation. So I bring my x down, bring my equal sign down. 15 minus 7 is 8. Circle my solution. And now I can always check it. And I do that by writing the equation down, the original equation, substituting that number 8 in for x, and seeing if I get a true statement. 8 plus 7 equals 15. I add 8 and 7, I get 15. 15 does equal 15, that's true. So then I know that I correctly solve this equation. X does equal 8. All right, our next equation is y minus 3 equals 11. I'll copy that down. All right, this time we have subtraction. The inverse of subtracting is adding. So right underneath, I'm going to write plus 3. Now, some people, to help keep everything in order and make sure that you're doing the same thing on both sides of the equal sign, they like to draw this line right down the middle here through the equal sign, so that you can see that you're adding 3 on the left side and you're coming over here and adding 3 on the right side. Okay? That might help you out in the beginning. All right, now, these numbers have to cancel. We learned that in the first problem. When I look at this, I'm wondering how 3 plus 3 cancels. But I got to remember, minus 3 is the same thing as plus negative 3. And then negative 3 plus 3 is 0, so that does cancel. I bring down my variable. I've isolated that. I bring down my equal sign. 11 plus 3 is 14. Circle my solution. All right, now I'm going to check. I copy down the original equation, y minus 3 equals 11. I substitute 14 in for y. Minus 3 equals 11. I have a true statement. 11 does equal 11. Therefore, y equals 14 is the correct solution. I feel good about that. All right, our next equation is 4x equals 24. And we remember, when a number is next to a variable, that's multiplication. So let me copy down 4x equals 24. I know that I'm multiplying by 4. The inverse would then be to divide by 4. This is how we show division. We divide by 4. I'm also going to come over to the right side and divide by 4. You want to be very careful not to show this as division. We don't use that as our division sign when solving equations. We use the fraction mark. All right, 4 divided by 4 is 1. So I get 1x, or simply just x. Don't have to write that 1 in front. Bring my equal sign down. 24 divided by 4 is 6. Circle my solution. All right, now I'm going to check it. My original equation is 4x equals 24. I'm substituting 6 in for x. 4 times 6 equals 24, hopefully. 4 times 6, that's 24. That's a true statement. 24 does equal 24. Check. X equals 6 was correct. All right, now I come over to my next equation. Y divided by 6 equals 12. Now I'm dealing with division. The inverse of dividing is multiplying. I'm going to show multiplication right here. 6 times I'm going to use a dot. If I want to use parentheses, that would be fine. I don't want to use an x, though, because now an x multiplication is going to get confusing with variables in the equation. So a dot or parentheses. I'm going to come over here, and I'll use parentheses over here. Multiply by 6. All right, now, think of this 6 as 6 over 1. And now you have two fractions that you're multiplying. And we learned how to cross cancel. 6 goes into 6 once, 6 goes into 6 once. Now I'm just left with 1y. I've isolated the variable. So y, bring my equal sign down, 12 times 6 is 72. Circle. I'm going to check, so I write down my original equation. Y divided by 6 equals 12. I substitute 72 in for y. 72 divided by 6. 72 divided by 6 does equal 12. I have a true statement, 12 equals 12, so I know my check was good, and my solution, x equals 72, is correct. Right now, common mistake with dividing, something you have to be careful of. When I have an equation like y divided by 6 equals 12, people will remember to multiply by 6, but they'll write it down here in the denominator. And that's not good, because if you wrote it down there, it looks like you're doing 6 times 6, which is 36. Now you have y over 36. You haven't isolated the variable. You didn't get rid of the 6. So that would be incorrect. Make sure that when you're multiplying by 6, you're doing it up here in the numerator. Okay, that way you can see that they're going to cancel. All right? That is solving one-step equations using inverse operations. Good luck on trying some of these problems, because the next thing that we're going to do after this is going to be solving two-step equations. Good thing is we're going to follow the same steps, though. Good luck, guys.